So now let us look at 3 series problem, and it all asks us to check whether the given series converges or diverges. Okay, and the main topic for this short video is to help you familiar with the ratio test. Okay, the ratio test, actually it is said that if this limit, if we denote it as capital L, and of course that means if this limit exists, and then if capital L is less than 1, then series converges absolutely. Okay, if capital L is greater than 1, the series diverge, and then when the capital L is equals 1, there is no conclusion. It's inclusive for this one, and then we need to think about the other type of methods, and then to check. Okay, so let's look at those 3 problems. So this is k over 200 and k, and k factorial. So if we apply the ratio test, so we're going to have a k plus 1 over a k, right? So that is k plus 1 factorial, right? Over 200 to the power k plus 1. And then over ak, which is this part, is equivalent to multiply the reciprocal of it. So it becomes into 200 to the power k over k factorial. Okay, so I didn't put this absolute value because both terms, those are positive. In fact, all the terms for this series are positive. So after simplification, you will have it's k plus 1 over 200, right? Over 200. And then let's take a look at this. You know, as k goes to infinity, and then this ratio also goes to infinity, right? And of course, this ratio gonna be greater than 1. So hence, this series, we can get the conclusion. It diverges, okay? It diverges. So that's easy. Now, look at the next 2 examples. Those are 2 alternative series, and then still we can apply ratio test. So an plus 1 over an absolute value, we're going to have it's negative 1 to the power of n plus 2. Keep in mind this original one is n plus 1, okay? N plus 1 factorial over 16 to the power n plus 1. And then again, over an is equivalent to multiply the reciprocal of it, which is going to be negative 1 to the power of n plus 1, n factorial, over 16 to the power of n, and I put an absolute value here. And turns out I can get rid of this. So after simplification, this is what I got. I got n plus 1 over 16. Okay, over 16. And it turns out that, you know, as n goes to infinity, this limit kind of goes to infinity. So easily we can see that this is diverge. Okay, this is diverge. So move on to the next one, which is the same thing. an plus 1 over an absolute value. So it's negative 1 to the power n plus 1. N plus 1 squared, 7 over 2 to the power n plus 1, over negative 1 n squared, so 2 over 7 n. And then, so this part we can simplify. So it turns out what I have here is n plus 1 squared times 2 over 7 over n squared. Okay. And then as you can verify that as n goes to infinity, so you see as n goes to infinity, when we evaluate this limit, so this part actually going to be 1 based on the L'Hopital rule, okay? And then so it turns out this is 2/7. So this ratio is less than 1. So we can get the conclusion that my series actually is converges absolutely. Okay, so it converges absolutely. So those are 3 very basic examples that help you get familiar with this ratio test. Okay, so it's pretty straightforward. Okay, hope you enjoy this short video. Thank you.